This next presentation is going to be on forces, F15s and skydivers. The learning objectives are going to be to describe the following forces: upthrust, thrust, air resistance and gravity, to draw forces diagrams for an aeroplane, to investigate the near miss of 2 skydivers and 2 F15s, to use knowledge of air resistance to describe how different body positions will change the terminal velocity of skydivers, and to make a time distance graph. Some of the forces I'd like to consider are upthrust, thrust, gravity and air resistance. If you want to have a little look at an F-15 taking off, I've included a little link to a video there. Thinking about thrust in F-15s, it is massive. So each engine produces around 25,000 to 29,000 pounds of thrust. When you're doing your forces diagrams later, try and convert that to newtons. So a very high thrust to weight ratio. So they only weigh around 45,000 pounds, only 45,000 pounds, but the amount of thrust generated by the engines is greater than this. So you can imagine it generates a vast amount of thrust, which allows them to accelerate quickly. The top speed of an F-15 being about 1,800 miles per hour, so they're rapid. They're in fact more than double the speed of sound. The power of these engines do help to lift the F-15s into the air, but also their wing, this aerofoil with its curved shape, also allows them to be lifted into the air. You get high pressure underneath the wing and low pressure on top. If you want to learn more about lift, I recommend watching these videos. I'll put a link in here, and I'll also put a link for the whole PowerPoint presentation in the description. I've also included a link to some worksheets. Now these are differentiated, so they're based on different levels for Key Stage 3 science. So you've got some that are level 3 to 5 and some that are higher than that, and they'll describe the task, they'll give you some key words, and then also in there is how you can achieve the different levels and what you need to do. In essence, I'd like you to draw some force diagrams, so think about whether it's going to be balanced or unbalanced in different situations, so considering when the plane's taking off, when it's landing, when it's cruising through the air at a constant speed. So just thinking about some different situations and how the different forces will look like. When drawing the force arrows, you can also consider the size of those arrows, making them bigger to represent a bigger force and smaller to represent a smaller force. So use the link, have a go at doing those and try and get as high a level as possible, push yourselves, try and improve it, give it a go. So, flying with F-15s. And this happened about a year ago to myself and another skydiver. This is his footage, not mine. I wasn't wearing a camera that day. It was an amazing experience. I'm not going to get to do that again. It's not something that's going to happen. It's not something that happens every day. It's not something to expect when you jump out of a plane for some F-15s to come flying underneath. So after the shock and swearing, I pretty much instantly changed my body position. We were on a tracking jump. It was a coach jump. I was being coached by the other skydiver to do some tracking. I'm not the greatest tracker in the world. I'm more like a plank, so we probably weren't moving that steep of an angle. It's probably quite a flat angle, the track, and we probably weren't going at that fast of a fall rate because of that. But as soon as I saw them, I went out of any sort of forward motion and went into a slow fall, sort of body position, a bit like a spider that doesn't want to go down the drain. So I made my body as big as possible to slow down my fall rate, to catch as much air, have as many air particles as possible bashing against me to make me slow down. Now you can see here that when the other skydiver saw the F-15s, looked round, saw them, it was around 13,000 foot. His altimeter is showing 12.9, so that's 12,900 foot. Underneath him, you can see the 2 little blobs, little F-15s. Now these were flying at 11,000 foot, according to the report that was released about this. We did decide to alter our flight path after seeing the F-15s. In the report about this, so which you can find a link to here, it did suggest that skydivers cannot control the directional speed that they travel. This is a misconception. This isn't correct. I went into slow fall and started heading back towards the other skydiver, who gestured to move in a direction away from the F15s, and that's what we did in a sort of belly position with forward motion, slight track going in that direction, while still looking around quite a lot to see if they were going to come back. I mean, my thoughts in my head at the time were really, I did consider opening, but then I considered some issues that might have come about from that, from turbulence and having an open parachute, and also I didn't really trust the F15s to not come back. I didn't know what they were up to, so I wanted to fall down below them as quickly as possible in a sort of controlled manner where I could see what was going on. The report also makes it clear that the F-15 pilots were not aware of the no-fly zone above Chatteris, where recreational parachute jumping does take place. However, they should have known about this, which should have been included in their training at Lake and Heath. In the report, the speed of the F-15s is reported as 345 miles per hour, which from my memory of the whole event seems pretty reasonable. They seem to be flying at a steady altitude as well, which would go along with the report, which says a flight level 110, which is about 11,000 foot depending on air pressure, so that's about correct, which would put them around 2,000 foot, 1,900 foot below us. With the speed 345, maybe that's what they were doing over the airfield, but I think afterwards they must have sped up, because I heard a sonic boom when I was landing, so that would suggest that they broke the sound barrier at some point. My opinion is that the F-15 pilots were aware that this was a no-fly zone. They're not stupid, they're trained professionals. I think what they were doing was they wanted to go on a flyby. They probably assumed that Chatteris would be dropping tandems from about 10,000 foot, tandems opening around 6,000, and thought they'd be able to fly over at 11,000 and get a nice view of the whole thing. Boom is created when an object moves faster than the speed of sound. It breaks the sound barrier and it creates a loud clapping noise on the ground, and that's what I heard when I was landing on that day. So that suggests to me that the F-15s did break the sound barrier. If you want to find out a little bit more about sonic booms, watch this video here. If you want to see some video clips of them, they do look pretty impressive when they form. Watch this one. I'd also like you to do a bit of research yourself into what are sound waves and what are the differences between longitudinal and transverse waves. Now, in the report it mentioned that skydivers can't control their direction and speed. This is a misconception. It's not true. Skydivers can control their direction and speed. If they couldn't control the direction, how would they be able to assemble amazing formations like this? How would we be able to do things like this? Go into sit fly, carve around the sky, come towards each other, take docks. These different positions were at different speeds due to the air hitting our bodies. When you're in a flat position, you've got a bigger surface area. There's more air hitting your body, therefore you won't fall as fast as when you're in a stand position, when you're coming through the air just like that. So you've got flat, more air hitting the body, creating more air resistance. When you're in a stand, you can go faster, head down faster still. So all these different body positions allow for different terminal velocities due to air resistance. When you first exit the aircraft, you're not going to be moving as fast. You're going to go through an acceleration profile, and that profile will be different depending on the position that your body is in. Here's a picture of me when around the time that I saw the F-15s. And I went into sort of some big spider mode, trying not to go down the plug hole. People do tracking jumps now where they go at steeper and steeper angles, increasing the speed of their tracking, almost travelling head down. So skydivers do have immense control over their body positions, and this takes a lot of skill to acquire this. Even greater speeds can be accomplished if you're falling through air at high altitudes where there's less air density, so there's less air resistance, less air particles to resist you, such as when Felix did his jump from the edge of space. If you want to see some incredible flying, just to demonstrate the different body positions, have a look at some of this video and some of the action you get from the wind games and athletes who fly in a tunnel who do some incredible things. This one's set to music. Just with slight change of their body position, the movement they achieve is incredible. So this is data that I've taken from the Dropzone.com. It's a data set that shows the acceleration profile of a skydiver in that flat position. So you've got time, it's t, time in seconds, and the distance they have fallen through the air in feet here. As you can see, this distance starts to go up by bigger and bigger figures, and eventually when it gets to that terminal velocity, it'll be at a steady rate per second. It'll be going up by the same amount of feet. So I want you to use this data to draw a time distance graph. Put your altitude on the y-axis and your time on the x-axis. And I want you to assume the skydiver leaves the plane, in this case at 15,000 feet, and deploys their parachute at 3,500 foot. As an extension activity, you can try and put in the parachute part of the journey, have a little research into canopy speeds, and think about some of the different variables you might need to consider to complete this part of the journey and to finish off your graph. I've also made a little graph. I've used the same acceleration profile as on the previous slide. Probably not entirely accurate, but it's close run thing. We probably weren't falling at exactly 120 mile per hour. I reckon we're probably falling a bit slower than that. We probably didn't exit the aircraft at exactly 15,000 feet either, but it would be close to that. So here's my data that I used. I put two important parts in bold. At 16 seconds into free fall, we would have been using this data set at 12,900 feet, and that's where the other skydiver, you can see he's got clear footage of the F15s at that height. The F15s were at roughly 11,000 feet, so just quick simple bit of maths there shows you that we're about 11 seconds apart if you're falling directly through the air and they were directly underneath. Here is my graph. Got the altitude at the y-axis, time on the x-axis. Again, you can try and finish that bit off if you want for a canopy flight. You can see the height where we spotted the F15s roughly at 12,900 foot, and the F15s, so that's 12,900 foot, and that's the F15s at 11,000 foot. Therefore, we were only about 11 seconds apart. You can work this out from the graph if you like by working your way down from there. There's a lovely straight line I drew there, and down from there, and then seeing what the difference is, and you can get the time from the graph, but you can also get it from the data set. Now, we mentioned earlier there's a pressure difference between this high pressure underneath pushing up against the wing and low pressure on top. That creates the lift. Now, at the end of the wings, this rolls over and creates these vortices, this turbulence that creates a wake behind your plane, and that was my worry. That was the thing that went through my head quite quickly. I think I have quite a few faults in these sort of situations, but that was the main reason why I decided not to open my parachute. You can find out more about wake turbulence in some of these links. This link here gives some examples of time that is needed between different aircrafts because of their turbulence. However, I don't think it's really an example of the amount of time that we needed between an F-15 and a parachute, so there's no hard hit rule for that one.